Good morning. Today I am going to do a video on your notes to explain it. I've also uploaded a copy of them as I always do for you guys. So I'm just going to explain this real quick so hopefully this video doesn't take too long and then you can get to your online game. So for today's activity, I linked a website for you guys to go to, and once you get there, you solve the literal equations, and if you get the answer right, you get to shoot a basket into the basketball goal. And then when you're done, you will upload a picture of your ending screen so that I know you finished all 10 questions. So I think it's a bit more of a fun activity instead of always having to do a worksheet. So make sure that you go to that link and that you answer all those questions. If it says that you can't play the game because it's blocked, that means you have your Adobe Flash blocked. And if you look in the top right of your search bar, you'll see a little puzzle piece. That's your Adobe Flash. You just have to unblock that and allow it to work. So let me explain what literal equations mean. I know you guys know the word literally because you say it all the time. This literally can't be real. Literally is so real. So a literal equation, it consists of letters, primarily letters. There might be a number or two. Solving literal equations is simply taking an equation with lots of letters and solving for one in particular. So you're just moving things around. It's exactly like what you do in a multi-step equation, but instead of actually combining like terms and adding and subtracting numbers together, you're just moving things around. It's just to help you understand the order that everything goes in and how you undo something. So when you're solving for something, you undo it. You move things away from it. So in this equation, 2 plus x equals a, there's no way I can actually solve this with a number because I have multiple things missing. But when it says to solve for x, that means I have to get x by itself. If it had said solve for 2, then I have to get 2 by itself. Solve for a, I have to get a by itself. Down here, solve for b means to get b by itself. So anytime you see something that says solve for and then it has a letter, it means basically get that letter by itself. Everything else needs to be on the other side of the equal sign. So if you look at this first line here, you have 2 plus x equals a. So x is not by itself. So what's over here with the x? A positive 2. So to move it to the other side, you have to do the opposite of it. So I'm going to subtract 2. But what you do to one side, you always do to the other. Well, I can't combine a and negative 2. They're two different types of terms. So you just write x equals a minus 2. So I'm literally just rewriting it. Instead of 2 plus x, I have x equals a minus 2. So it should be the opposite of what you started with. And then I wrote some steps down here for you right here. Follow the order of operations forward when you're doing a problem and backwards when you're undoing it. So as you know, if there is any denominators, we have to get rid of those first because we can't get to anything on our numerators before that's gone. But anytime you're down to a more simple form of your equation, we always add or subtract those constants, and then we multiply or divide away those coefficients. Well, that's backwards from PEMDAS, right? PEMDAS would have us do multiplication, exponents, dividing, all of that before we do any simple adding or subtracting. But when you're undoing them, that's why we add or subtract those constants first, and then multiply and divide. So we do this backwards when we're undoing problems. And then whatever we do on one side, we always have to do it on the other. And when you're moving things, you use your inverse operation. Remember, if it's times 2 on one side, the inverse of that is divided by 2. If it's plus 2 on one side, the inverse of that is minus 2. So we always do the opposite to move them. So for this example right here that I put beside these steps, if it wants us to solve for b, and this is our equation, a equals 1/2 b times h. That's your area of a triangle, 1/2 base times height. So to solve for b, that means get b by itself. So right now there's some things over here on this side of the equal sign that need to go. So the first thing I'm going to do is get rid of this h. There's nothing that's been added or subtracted. So the only thing I have is multiplication and division that I'm seeing. I see multiplication and I see division. So I can't do adding or subtracting first because there's none of that. So to get rid of times h, I divide by h. Remember, whatever you're trying to get rid of, that's what you do in your inverse operation. I've seen some of you guys try to get things away from your letter and you divide by your letter. So if we were trying to get b by itself right here, some of you guys would have divided by b. That gets rid of b. We're not trying to get rid of b, we're trying to get rid of h. So be careful what you get rid of. So that cancels that, and what you do to one side you have to do to the other. So when we come down here, we just rewrite it, a divided by h, and we're left with 1/2 b. Well, to get rid of divided by 2, we times by 2. And I do it to the other side as well. So now I have 2a divided by h equals b. We could have left that 1 there, 1b, but we know 1 times anything, it doesn't change anything. So at this point, we've just rearranged it. We moved all the letters and numbers around, and now most of them are over there, and b is by itself. The biggest thing that I'm going to probably notice that you guys struggle with for this is you're going to get hung up on the fact that you can't simplify stuff. When you divided by this h on this side and on that side, if I were to ask you, okay, when you come down here, what do you write? You guys would not have been able to say a divided by h. Like, for some reason, y'all think this gets simplified and this becomes something, and in a literal equation, it does not. There is no actual solving. It's just rearranging. So if this is what you have, this is what you bring down. And don't overthink it and think it's supposed to be something more. If I multiply both sides by 2, well, this just becomes 2 times a divided by h. That's it. There's nothing more you can do. There's no other like terms. And that's the thing with literal equations. You won't really have like terms because they're all different terms. So I put 2 examples down here for you that I'm going to go through, and then I'll let you get to your online game. So for this example, AB plus C divided by D equals F. The original problem is in green. I said to solve for B. Okay, so I know when I say do PEMDAS backwards, some of you see plus C, like you see that first and you think, okay, I need to get rid of that. But remember, you can't get to anything on top of a fraction until that denominator is gone. And I put that down here for you. If the letter you're solving for is a numerator, you first have to get rid of the denominator. This denominator is trapping everything up top. You can't even get to it until this is gone. So that goes first. So the opposite of divided by D, because I have to get rid of that, is times by D. And I'll do that to both sides because you have to keep it even. So these two will cancel each other out. So that's gone completely. So when I come down here, I only write what's left. So if that's gone, what's left is my numerator, AB plus C. And then on this side, I just have F times D. Again, don't overthink it. This isn't going to turn into anything. These are different letters. You don't know what they are. You can't combine them. You just write them side by side. Now, if I'm trying to get B by itself, first we add or subtract anything that's just hanging out by itself. And I have just a simple plus C. That's easy. That's addition. So I'm going to get rid of that first. So the opposite of plus C is minus C. So if I do that to one side, I do it to the other. And now that's gone, and I'm left with just AB. And over here, when I have FD minus C, I can't combine them. They're all different letters. If it was F times D plus C minus C, I could combine the plus C minus C, but there's no other C here, right? This is the only one, so I can't combine them, so I'm just going to rewrite them side by side. The last thing that's stuck to my B that I'm trying to solve for is a times A. So the opposite of times A is divided by A. So that cancels each other, and I have to do it to the other side as well. And that's it. That's my answer. B equals F times D minus C divided by A. So we're not actually solving. We're just rearranging. So if this was the original problem, this is what F equals. F equals all of that. But I want you to tell me what B equals. So we had to move that and that and that. And we did. We got B by itself and we moved everything else away. But we had to do it in the right order to get the right answer. And the other example I'm going to show you is A parentheses B plus C divided by D equals E. So again, we have a bunch up top, but we can't get to it because of our denominator. So I'm going to multiply by that denominator to get rid of it, because the opposite of division is multiplication. So those two cancel out, and I'm left with E times D, and then it's just equal to A times B plus C. So I got my numerator free, and now I need to start moving things away because I'm trying to solve for C, and it's up top, it's trapped. So yeah, I got rid of my denominator, but I can't just go inside these parentheses and pull C out. There's an order here. I have to get rid of these parentheses, and everything inside of this parentheses is being trapped by the A outside of it that's holding it there. So now, again, we're like pulling things away to get to the middle right here, to get to the C. So we got rid of our denominator. Now we have to get rid of this outside number, or it's a letter because it's holding the place of a number we don't know. So to get rid of times A, we divide by A, right? Multiplication and division are each other's inverse. And what we do to one side, we have to do to the other. So now I'm going to divide this side by A. Now that those are gone, I'm left with just B plus C equals E times D divided by A. And now if I'm trying to get C by itself, what's the opposite of just B? Negative B. So if I have a B and then I subtract a B, I have nothing. I have 0. So that's gone, but you have to do it to the other side, minus B. And because there's no other B here, there's no other like terms, I just write it out beside of it. So C equals E times D divided by A minus B. And again, the note that I put down here is that you can't get into parentheses until everything outside of it's gone. So again, once you get it down to a simpler form, you try to add or subtract things first, and then you would multiply. But in this case, the multiplication was trapping multiple terms inside. So we had to get rid of that first. So there are a few exceptions to the rule of doing PEMDAS backwards. Just look at it as a big structure. The bottom is the foundation, holding anything that's on top of it together. So you can't get to anything on top until that bottom foundation is gone, if you have fractions. Once you get that gone, these are walls. You got to get rid of the walls, and then you can get to the inside. So if you think about it that way, it might be more helpful. And again, you're not actually doing any math here. We're just rearranging by doing each other's inverses. And so same thing up here. These multiplications that were stuck beside my B were like walls. So I had to do the opposite of them to get rid of them. The opposite of this to get rid of it. And then you'll get your B by itself. If there are no walls or foundation and you just have a few things attached to it, it's really easy to start moving things away. Those are always much easier. And one more thing I'd like to add, this doesn't have to go in your notes. I'm just going to write it on a blank sheet of paper for you. A really easy example. Let me see here. Okay, one more thing. If you had this equation and I said solve for A, so solve for A, what you are noticing is that A is being multiplied by B and multiplied by 2. So instead of dividing by B and then later dividing by 2, we can just go ahead and divide by both of those at the same time. So we can just say divided by 2B. So you can do multiple things at the same time, right? Because they're both being multiplied, so we can divide them both. Divided by 2B, right? Because A times 2 gets canceled when it's divided by 2. And A times B, that gets canceled when it's divided by B. So this 2 cancels with that 2. This B cancels with that B. So you can do that because you can pull them both out at the same time. And then over here, this B cancels with this B. And 4 divided by 2 is just 2. So really what you're just left with is 2C equals A. So I just wanted to show you that because that's less work than having to do divided by 2 and then divided by B. So in the online game that you play, there are going to be some questions like this where some of the letters will cancel out on the answered side and some of the numbers might reduce down to a fraction or a more simple whole number. But you'll notice that they'll pull some of those out at the same time just to save some time and skip a step. So you can do that as well. So good luck on your game today. If you have any questions about playing it or taking your screenshot, as always, you can leave a comment or you can email me at any time during the day. All right, thanks guys.